algebra students. Mr. Lawrence here with your flipped lesson, and we're going to be solving systems of linear equations by elimination. And I've got to warn you that elimination is, in my experience, not as accurate or as reliable as substitution. When I was your age and I was learning how to do this, I always did it by elimination. I perhaps understood it better, but I found that I made lots of mistakes. When I got older, I started doing more by substitution, and I noticed a lot of the mistakes started disappearing. So a lot of you are going to be tempted to always do this by elimination, and I just wanted to warn you about that. Okay, so let's see what our system looks like. And let me see, where did my system go that I wanted to use? Okay, let's say we had, let's say we have the equation that 14x plus 21y equal 28. And then we also had the equation negative 11x minus 21y equals 5. Now, to solve one of these equations for either x or y, gets pretty ugly. You know, you're going to have to subtract then the variable you're not solving for, and then you're going to have to divide by coefficients of either 14 or 21 or negative 11 or negative 21, and it just isn't going to be very pretty. But one thing I do notice is that I have a positive 21 for a coefficient on the first equation for y, and for the second equation I have a negative 21. And I know that positives and negatives cancel each other out in addition. So I'm going to add these two equations together. And I'm going to get 14x plus negative 11x, which will be 3x. Those are going to cancel. And then I'm going to get 28 plus 5, which is 33. Now that I have one equation with one variable, I can just solve my one-step equation. And I'm going to get x equals 3. All right, now I have to take this 3 and plug it into one of the original equations. And so I'll plug it into the first one. I'm going to do 14 times 3 plus 21y equals 28. And 14 times 3, I believe, is 42 plus 21y, which equals 28. Then I'm going to subtract 42 from each side. Okay, I know those are going to cancel. I'm going to get 21y, and I think that's going to be negative 14, right? 42 minus 28 would be 14, and so 28 minus 42 would be negative 14. And then I'm going to divide by 21 on both sides. And then y is going to equal, if I divide by 7, a negative 2/3. And so my x coordinate is 3, and my y coordinate is negative 2/3. And there's my solution. Now some of you go, wow, that was so much easier. Well, sometimes yes and sometimes no. You have to be a master of all the different methods so you know which one to use. By the way, in the video yesterday, I mentioned about what this is. These are linear equations, right? This is a linear equation in standard form, right? And so if I graphed it, I'd get a line, and this one is a linear equation almost in standard form, right? And if I graphed it, I would get a line. This point is the place where the lines cross. That's what the solution is. We're finding a place where the lines cross. Now this has some really cool applications. We're not going to get into the applications today so much, but I wanted to plant a seed for the future. Okay, let's take a look at another problem. Okay, let's consider this system. Now, in this one, I don't have coefficients that match, but, oops, hold on one second. I don't have coefficients that match, like I just said, but I noticed if I multiply this top equation through by 2 on both sides, of course, I have to do it on both sides. This top equation will become negative 4x plus 2y which will equal 24. And then the bottom equation stays the same, and I will get negative 4 here. Now notice my coefficients on x's match in this case with opposite signs, and that's the goal. So I can manipulate the equations, kind of make them do what I want to do. If I add these together, those will cancel. I'll get a 4y, I'll get 20, and then dividing by 4 will yield the answer that y equals 5. Okay, so that's part of my solution. Now, I've got to substitute that 5 in to either one of the original equations, like this one I could, or I could do it to that one, or I could do it to this third one here, which is twice the original. It looks like the simplest place to substitute it in might be this first one. So I'm going to write negative 2x plus 5. That's going to equal 12. I'm going to get negative 2x, and that's going to equal 7. I subtracted 5 from each side. Going to divide by negative 2, and x is going to equal negative 3.5. So my x coordinate is negative 3.5. Okay, so I can multiply one of the equations to get it so that they'll match. Now, notice my answers don't always come out pretty. The y came out nice, but the x coordinate did not. All right, let's try another one that's a little bit more challenging. Okay, let's take a look at this one. Now, um, nothing matches. And nothing is obviously a multiple of each other. Like in the last one, I could just double the top equation, and I got my x coefficients to match, and opposite signs and cancel out. But in this case, my coefficients on x are not multiples of each other. My coefficients on y are not multiples of each other. Well, what you can do in a situation like this is you can decide, well, do I want to get rid of my x's or my y's? I think in this case it'll be easier to get rid of my y's. And I'm going to multiply by a number that will cause my y's to have the same coefficient with opposite signs. Well, in other words, I need the least common multiple of 4 and 5. Well, that would be 20, right? I'm not going to multiply by 20. I'm going to multiply by what will turn this number here into 20. So I'm going to multiply by 5 in the top equation. But in the bottom equation, I'm going to multiply by 4. And when I do that, watch what happens. My top equation becomes 35x minus 20y equals 115, I believe. Okay, the bottom equation becomes negative 12x plus 20y, and that'll equal 0. And notice here, now my y's have the same coefficient with opposite signs. They're additive inverses of each other. How did I do that? Well, I used the least common multiple of negative 4 and positive 5. Had I decided to get rid of the x's, I would need the least common multiple of 3 and 7, which would be 21, in which case I would have multiplied by 3 here and by 7 there. But I didn't do it that way. I thought it would be easier to do it this way. All right, so let's do some addition. And let's get 23x and 115. Now, if I've been paying attention to my own work, I know right there I multiplied 23 times 5 and got 115. So when I divide by 23 on both sides, I'm going to get x equals 5. You can verify that if you like. So part of my solution is 5, the x part of my point. To get the y coordinate, I'm going to substitute 5 into one of the original equations. I personally think it'll be this one will be easier. So we're going to negative 3 times 5 plus 5y equals 0. Negative 15 plus 5y equals 0. Add 15 to both sides. I'm going to get 5y equals 15. Divide by 5, divide by 5. Y is going to equal 3. So the solution for this system is the 0.53. I know this video is going to go a little bit longer, but we're going to do one more example like that because I need you to understand what to do. Hold on one second. Okay, so here's one. Again, they don't match very prettily. I think this time I'm going to multiply to get rid of my x's. I don't really want to be getting the least common multiple of 8 and 7. I think it makes my numbers too big. I'd rather get the least common multiple of 2 and 5, but watch what I'm going to do. I'm going to multiply the top equation by 5, but I'm not going to multiply the bottom equation by 2. Anybody know what I'm going to do? Think about it for a second. I'm going to multiply it by -2. Watch what will happen when I do that. My top equation should become 10x minus 40y, and that'll equal -50. The bottom equation will equal -10x minus 14y, which will equal -62. All right. Notice how my x coefficients have the same sign, same coefficient, but different signs. Had I not multiplied by a -2, only done a +2, they would have been 10x and 10x, which wouldn't cancel out when I add them. So those are going to cancel. This is becoming -54y, and this is going to become -112, I believe. All right, so I'm going to divide each side by -54. I know my answer is going to be positive, and I'm thinking that's going to go in 3 times. So the y-coordinate of my solution is 3. To find the x-coordinate, I'm going to substitute that in. I'll go ahead and substitute in the first equation, 2x minus 8 times 3 equals -10. I'll get 2x minus 24 equals -10. Adding 24 to both sides will get me 2x equals 14. X will equal 7. And these two lines cross at the point 7, 3. All right, that's your flipped lesson for today, elimination method. We have to make sure that either the coefficients on x or the coefficients on y are the same, but additive inverses of each other. In other words, one has to be positive and one has to be negative with the same absolute value. All right, Mr. Lawrence signing off. Good night, everybody.